In the last of these little videos relating to the 200th anniversary of the Cambridge Philosophical Society, I talked about one particular thread of science which has run throughout their 200 years, and that was the attempt to use mathematical methods in the physical sciences, very much in the tradition of Newton. Well, in the latter half of the 19th century, a parallel thread began to develop where scientists started to get very interested in applying mathematical methods to the life sciences. This was partly sparked by Darwin's work and the growth in interest in evolution and the wish to put that on a firm footing. So that's the story of this little talk. It formed another of the themes of the exhibition. Here you see it in its position in the original room, Discovering a Science of Man. And essentially this is the story of the kind of science you need for applying to biology, which is statistics, a different kind of thing than the physical sciences called for. So this is the story of the development of modern statistics, and on the side of that is the development of the modern theory of mathematical biology and mathematical genetics. Our story begins with this man, Francis Galton. Now, these days Galton is a rather controversial figure, and I will return to that in a few minutes. But all I need to say for the moment is that we must be very careful about reinterpreting the past with the eyes of the present. Hindsight is a wonderful thing. In Galton's lifetime, he was not a controversial figure at all. He was a respected scientist. He worked on many topics in the mainstream of science. He was a cousin of Charles Darwin, and like Darwin, in his relatively young years, he travelled and produced the book that you see the cover sheet of here. He travelled to Africa. Here are some pictures from that book. He became interested in anthropology and the varieties of humans. And maybe that interest was what lay behind the particular thing we're interested in this story, which came a few years later. Galton got interested in anthropometrics. That's the idea of measuring the physical size, shape, strength of people with a view to an investigation. The question they were interested in asking is, if you knew enough about the physical characteristics of a person, could you deduce something about their propensities? I think they were interested in the possibility that you might detect criminal types or otherwise undesirable characters like that. In the Cambridge context, which I'll come to in a moment, the thing they were most interested in was whether you could tell by doing physical measurements how good a degree people were going to get. Could you detect first-class people from past degree students by looking at the size of their head and therefore the size of their brain? Did clever people have bigger brains? Well, here is Galton's first anthropometric laboratory. He set it up in London at an international exhibition, and this was open to the public. Anyone could come in. They had to pay threepence for the privilege, and then these various mysterious instruments you can see in this photograph were exercised on them, and they were measured. Physical measurements, their eyesight, their strength, all sorts of things were recorded. Once this project had been going for a bit, Galton came to Cambridge and he gave a talk to the Philosophical Society about this wonderful new science that he was starting. The Philosophical Society got excited about the possibilities, and so they set up their own thing. Here are some of the instruments that are used in these anthropometric studies for measuring width of the head and what have you, and these instruments themselves have a Cambridge connection. Horace Darwin, one of the sons of Charles Darwin, had been involved in setting up a company called Cambridge Scientific Instruments, which made, back in those days, various mechanical instruments for preparing microscope specimens and what have you. His company made a line of these anthropometric measuring instruments. Not relevant to this story, but the company continued in existence for a long time until the 1960s, and one thing they were famous for in the 20th century was that they produced the first commercial scanning electron microscope. But back to anthropometrics. A Cambridge anthropometrics project was started in 1886, and it was run by the Philosophical Society. And it was open to anyone who had access to their library. The librarian did the measurements, and that meant they were all members of the university, a much more uniform clientele than Galton's experiment, where he got people of all types. Well, the project ran for over 2 decades, and it produced over 9,000 cards like these, which you see in this picture here. And the Philosophical Society still has them filed away in their archives. This was very popular work, and everybody wanted part of it. Again, they had to pay threepence for the privilege of being measured. But in among these many, many, many cards were a number of people who later became famous. Here is the card for Ernest Rutherford, the physicist, aged 26, so he'd probably fairly recently arrived in Cambridge, and this tells you that he had fair hair that was straight. It tells you the dimensions of his head and his face. It tells you how long his nose was. It also tells you some things about his strength, his pull as an archer and so on, and his eyesight. Just as one more example, here's the corresponding card for John Maynard Keynes, the economist. And we can learn from this that he was a little taller than Rutherford, but nowhere near as strong. All the strength measurements are significantly lower than for Rutherford. So they collected lots and lots and lots of data. What do you do with it? Well, that is the beginnings of a theme, what we now call big data, which is very much still with us. And a number of subsequently famous people were connected with the effort to analyse large data sets like this. And the first name in our story is this chap, John Venn. Now, what do we know the name of John Venn for? We know him first of all not for his analysis of anthropometrics, but for his famous diagrams. He was interested in the theory of probability. And this, as a matter of interest, a mild diversion, this is the very first publication by Venn containing one of his diagrams, and the title of the paper is on the employment of geometrical diagrams for the sensible representation of logical propositions. And where was this important paper published? In the Proceedings of the Cambridge Philosophical Society. Venn was a fellow of Gondolin Keyes College and a Cambridge worthy for many years, to the extent that the college now has a commemorative stained glass window commemorating Venn and embodying one of his famous diagrams. Bear this in mind, we'll come to another of their stained glass windows a little later. So what did Venn do? Well, he did the very first study of the Cambridge anthropometrics data, but he did it rather early. Of course, the Philosophical Society were interested in how their exciting new project was going, and as so often happens, they wanted information before there was really enough data to get to grips with it. So Venn did a preliminary analysis based on the relatively early data here, and he tentatively concluded that it did look as if there was a correlation. They looked at students who ended up with different classes of degree, first class, second class and so on, and it did look as if the ones with first classes had bigger heads and therefore bigger brains. Interesting, but they didn't really have all the data. Things then rested for a while, and another pioneering figure in the world of probability and statistics got involved. Now here's Galton again, we saw him earlier, but on the right you see Galton near the end of his life, and sitting next to him is the figure we're interested in next, who is called Pearson. Someone whose name is still attached to important theorems and quantities in the theory of probability and statistics. Pearson is sitting with Galton here because he was his acolyte, and indeed he wrote an encyclopedic biography of Galton. Pearson was based in London, but he was interested in the same questions, analysing data on humans to see if you could find correlations of physical characteristics with various mental qualities. So he got permission to get hold of the Cambridge data, ship it off to London and analyse it. By then they had much more of the data, so he did some analysis, and he was assisted by people, in particular by a colleague in London, Alice Lee. And here is what she wrote in her conclusions of the study, that in no single case is the correlation sufficiently large to predict with even a moderate degree of probability intellectual capacity from the physical characters of the individual. So they didn't agree with Venn's preliminary investigation of this data. There was no clear correlation. Bad news for Cambridge College interviewers. You can't predict who's going to get a first-class degree simply by measuring the size of their head when they come in. There is no reliable correlation. The story of the development of statistical methods then continues with this man, Ronald Fisher, R.A. Fisher. Now, Fisher is a very controversial figure. He has a modern reputation with two different sides, and they could not be more strongly contrasting. The good things first. Fisher is universally acknowledged as the founding figure in modern statistics. He was interested in this growing idea of big data. Anthropometric data was one of the things, but the thing he was most involved in was data from plant breeders, because of the effort to put the theory of evolution, the theory of heredity, onto a mathematical footing. Well, Fisher did that. He originated many of the ideas that are still the bread and butter of statistics, the analysis of variance, for example. We still talk about Fisher information. But in addition to that, he is one of the three figures who are always cited as the originators of the modern synthesis of mathematical biology, mathematical genetics. That's the good side of Fisher's reputation. But there is a dark side. Fisher, along with Galton and Pearson, was involved with the eugenics movement. But Fisher went beyond that. He espoused views that were controversial in his own lifetime and which are now considered quite unambiguously racist. Well, there's an irony here. These days we know for certain that any attempt to pigeonhole people into neat categories as types or races is a statistical nonsense. And how do we know this? We know it because since Fisher's time, people have analysed a huge amount of data, especially modern genomics data. And they did this analysis using precisely the statistical methods that Fisher pioneered. The conclusions are similar to what we heard earlier from Alice Lee relating to the Cambridge anthropometrics data. If you analyse enough data, carefully enough, you find that the concept of race virtually disappears. All humans are hybrids. Back in our deep evolutionary past, all humans were originally Africans, and it now looks as if a lot of us are part Neanderthal as well. These two sides of Fisher's reputation are neatly encapsulated in this image. Fisher, like Venn, was a fellow at Gonville and Caius College, and in celebration of his undoubted scientific achievements, he too had a commemorative stained glass window. Here you see it. It shows what's called a Latin square. You can notice that every column and every row has one example of each colour, and they're never repeated anywhere. Fisher used diagrams like these in his influential theory of the systematic design of experiments. Well, a couple of years ago, present and past members of the college got up a petition objecting to this celebration of a notorious racist. The college authorities agreed with the petitioners, and the window was removed in 2020. Gonville and Caius was not the only educational establishment grappling with this issue. University College London had a Centre for Genetics Research, also named after Fisher, and they also renamed it in 2020. Here's what they said about that. Fisher's scientific legacy will rightly persist in all branches of the sciences he helped create. And in our commitment to scientific excellence and social equality, we have elected to honour this work, but not his name.